Hi everyone, and welcome to this lesson on the analysis with the fundamental logical operations, which really just means how you use the fundamental operations such as not, or, and exclusive or. The first thing we're going to talk about is order of operations. And let's do an example to see why we need to talk about the order of operations. Consider the statement, false and true, or true. If we compute the and first, then we're going to have false and true is false. Then false or true is true. So we get true in the end. But if we do the or first, then true or true is true. And then false and true is false. So what is the value of false and true or true? Is it true or is it false? Well, it isn't well defined. We need to somehow specify which operation should come first, the or the and. So, of course, mathematicians don't like these ambiguous statements, and that's why we need to define some sort of order of operations. And the first operation that's just agreed upon is negation. So, negation is first. Therefore, if we have a statement like true or not true, the not true is the thing that's computed first, and not true is going to be false. Then true or false is true. On the next level, and, or, and exclusive or are all second after negation, and they're all on the same level of order of operations. So how do we specify whether we want to use and or first whenever doing something like false and true or true that we saw above? When things are on the same level, or even when they aren't, we use parentheses to impose an order of operations. So parentheses kind of override everything, and that way we can even override, for example, a negation. So say I wanted to compute not true or false. Well, if I write it this way, I'm going to have to compute not true first, and that's going to give me false. Then false and false is false. But I really wanted the negation to be of true and false, so I wanted it to be the last operation. And so I'm going to use parentheses around the true and false to mean compute this first. So with parentheses, true and false is false. Then we do the negation, and not false is true. So we can use parentheses to say which operation is first in false and true or true. If I put parentheses here, that means do and first, so I'm going to get a true result. And if parentheses are around here, I'm going to do or first, meaning I'm going to get false. Not only can you use the parentheses to say which one should come first, but you have to use the parentheses. Because, for example, false and true or true is actually a logically ambiguous statement. It doesn't have any value. So you have to use the parentheses to get a result. Now we're going to look at some of the basic properties of these operations. So we've talked about the order of operations, not, or, and exclusive or. So we can now compute with them. The first basic property we're going to look at is on negation. So negation only takes in one input and it flips it to the other input. And if you negate something twice, it just goes back to what it was originally. So for any statement, not P is just the same thing as P. And you can verify this by checking it for every possible value, right? So if I take not true, well, first I compute not true, and that gives me false. Then not false is true. So not true is true. And similarly, not false is false. So since we only have a 2-point space in logic, we've just checked everything in the entire space. So whatever value P has, not P is always P. Also, and, or, and exclusive or are both associative and commutative. So whenever we say these are associative, what we mean is if there are three operations and we're looking at, for example, P and Q and R, it doesn't matter in that case which order you compute the ands because all the operations are ands. And likewise, if all the operations were ors, it wouldn't matter. So if I had P or Q or R, it could even say P or Q or R or S. I could do them in any order. So with two ands, P and Q and R, I can do P and Q first, or I can do the Q and R first. It doesn't matter which one I choose to do first, they're equal. They're always going to be the same. And since it is associative, we can actually just write P and Q and R without parentheses. As long as all the operations are the same, you don't need parentheses, it's still well defined. It's also commutative. So P and Q equals Q and P. It doesn't matter if you want to swap which one's first or second. Right? So true and true is true, and then true and false, false and true and false and false. They're all false. It doesn't matter if you swap true and false, or if you have two trues, you can swap them, it's still true. Same thing with or and exclusive or. You can do them in any order, and you can reverse the orders of the statements, and you'll still get the same result. A more interesting result is distribution. So and distributes over or, and or distributes over and. So what do I mean by that? So let's look at this statement. Inside this parentheses, I have a Q and R, and then outside of the parentheses there's a P or. And what I can do is I can distribute this P or to both terms. So I can make this a P or Q and a P or R. And now the and is the second operation, or it's the operation on the outside of the parentheses. So same thing happens, let me clear that off a little bit, with P and Q or R. So this P and can come inside to both places, so P and Q, and then P and R, and then the or goes to the outside. To show that this is true, you can use a truth table. So it looks like we show that or distributes over and with this truth table. To create the truth table, you first plug in all possible values of inputs, right? So here on this side, on the left of the inputs. So one case could be the statement P is true, Q is false, and R is true. And that would be here. P is true, Q is false, and R is true. And in that case, Q and R, well, false and true is false, so Q and R is false. And then if I take Q and R or P, in our case, this is false, and P is true, so the or is true. Then if I look at this row, false or true or false, P or Q is true because that's true or false is true. I'm sorry, this is not the row that we looked at above. We want to look at true, false, true. So let's look at P is true, Q is false, R is true. Right, so P or Q is true because that's true or false. P or R, that's true or true, so that's true. And then we want to compute P or Q and P or R. So this is true and true, which equals true. So you can compute across this way through all the rows, and notice that the end result is true here, and the end result is true here. And no matter which two rows you pick, the end results are always the same. So if we pick false, false, true, for example, the end result is false. And if we pick false, false, true here, the end result is false. So no matter what the inputs are, we always get the same result at the end, and therefore this statement and this statement, these two statements are equal because they're always the same. Next we will look at De Morgan's law, which relates the negation to and or. So the negation of P and Q is not P or not Q. And the negation of P or Q is not P and not Q. So if you want to distribute this negation to each term in the parentheses, you have to flip over the middle. So this gets flipped over. And same no matter which way it's facing. So if it's or, it gets flipped over to and if it's and, it gets flipped to or. So for this example, we're just going to consider a statement in English. So we're going to let P be the statement, I want green beans, and Q is the statement, I want lima beans. Not P or Q would say, I do not want green beans or lima beans, if we translate it into English. And the statement in English of not P and not Q would be, I do not want green beans and I do not want lima beans. Notice that both of these statements mean the same thing, that you don't want either kinds of beans. I don't want green beans or lima beans, I don't want green beans, and I don't want lima beans. However, the statement not P or not Q is different, so you can't distribute the negation and keep the symbol the same. You have to flip it over. So not P or not Q would say, I do not want green beans, or I do not want lima beans. It sounds like you don't want one or the other, but you might be okay with one of them, which is different than saying you don't want both of them. So these two statements are not the same, even in English. The meaning will not be the same. So you got to remember to flip that operation in the middle whenever you're doing De Morgan's laws. That's all for this lesson. I'll see you all in the next one.